Okay, proportional ratios, which are two equivalent ratios, you can use them for a few different things, and there are a few different ways to solve it. You can use as many of these as you want. Some problems are going to be easier to use one strategy. Some problems you might use different strategies. So it's whatever you're most comfortable with. I don't care how you solve it. But if I were you, I would look to find out the easiest way, right? It's good to have some of these tools in your toolbox to be able to solve these problems. So again, when you're talking about a proportional ratio, this to that, as equal to so much of this to that, right? So the values are going to be equivalent. Now you can look at it as fractions, you can look at it however you want, but in order to find that missing value, there are a few strategies to use. These are the ones that I like to talk about. You can go across the river. These are kind of my own made up names. Across the river, you can go up and down the ladder. You can always cross multiply, or I like to say break it down, reduce it down, and then build it back up. So those are four different strategies. You can solve the same problem. I'm going to show you that now, but let's take a look at each one. So with the cross the river. All right, so when you go across the river, what I mean by that is the equal sign here being your river. All right, so when we go across the river, whatever you do at the top, you got to do the bottom. It's probably one of the most one of my most prominent sayings, I guess. One thing that I say the most: whatever you do at the top, you got to do the bottom, right? These are equal to each other, and vice versa. Whatever you do at the bottom, you got to do the top. So whichever way we're looking at, and again, we want to find out what number makes that statement true. 3 is to 6 as something is to 12, and we want to know what number goes there. Well, one way you could do that is going across the river. And again, you always go in the direction of your unknown, right? And again, you can have a box there, or you can have a variable, right, in for number. And we want to know what that number is. So however they present it, don't get confused by that. It's still saying what number is your numerator here. What number makes that statement true? So 3 is to 6 is something is to 12. Now, for us, how do I get from 6 to 12? Well, it's getting bigger, you multiply. If it gets smaller, you divide, right? We're talking about multiplying and dividing here. I wouldn't say it's plus 6 because that wouldn't make that ratio true. But we know that we can multiply by a factor of 2, 6 times 2, and whatever you do at the bottom, you get it at the top. So we know that it's twice as much on the right side, right? 6 times 2 is 12, so 3 times 2 means that that answer is 6. So 3 is to 6 as 6 is to 12. That's going across the river. Now, we got to talk about going up and down the ladder. Now, again, you always go toward your unknown. You always go to the unknown towards your variable. So, again, there's my unknown variable. I want to say what number here makes this statement true. 3 is to 6 is something is to 12. Going up and down the ladder. Now, again, we're going up the ladder because that's where our unknown is. So, we look at this. Probably the biggest part, if you got your factor right, but a lot of people will use the wrong operation. For instance, multiplying by that factor instead of dividing. It's very common, but make sure you're just going towards your variable. So I'm going up the ladder here, right? And I go from 6 to 3, we divide by 2. So we do the same thing on the other side, right? Anything you do on one side, you gotta do the other. So I divide by 2 on this side. 12 divided by 2 is, yes indeed, 6. So let's going up the ladder, and in a situation where your variable is on the bottom, your unknown is on your denominator, then you would go down the ladder. But same type of scenario there. Okay. All right. Now, this one always works. Cross multiplying is always available for you. When you cross multiply, you multiply along your diagonal. So we would multiply in this case 3 times 12, which is 36, and we set that equal to our multiplication in the other direction, which is 6 times our variable, all right, 6 in. Anything times the numbers is good. 6n is 6 times n. But we solve for n. Okay, first step is to multiply, and then we got to get that variable by itself because we want to know what n is. I don't want to know what 6 times n is. I want to know what n is. So we do the opposite of multiply by 6, which is to divide by 6. Anything you do to one side, you got to do the other. And n equals 36 divided by 6, which is 6. So n equals 6. Once again, 3 is to 6 as 6 is to 12. Cross multiplying is an always rule. No matter what problem is, that will always work. Okay. Now the last one I wanted to tell you about, reduce and build up. Again, we're going to break this fraction down. If we look at that 3/6 as a fraction, we can reduce it. We can divide by a common factor of 3 on top and bottom. That makes that 1. 6 divided by 3 is 2. And now we can build up from there. Now, again, doesn't matter from here. You can go across the river, up down a ladder. Doesn't matter. Let's go build it back up. To get from 2 to 12, multiply by a factor of 6. Do the same thing to the top. 1 times 6 is indeed, ladies and gentlemen, 6. So 4 different strategies. Solve the exact same problem. Got the exact same answer. And again, whatever is easiest for you.